Hey everyone, thanks for making it out early on the last day of Monitorama. I'm Richard Benwell, I'm founder and CEO of Squared Up. We provide a unified visibility layer on top of all of your observability data, no matter where it lives. And I think I've sort of met many of you up at the booth upstairs, so thanks for swinging by and talking to us at the booth. Today I'm talking about joining the dots with Open Telemetry semantic conventions. But before I get to that, I just wanted to frame the conversation around what I see as the two sides of observability data. On one side, we have the question of how do I collect and store that data? And the problem there is how to do that at scale. And there's two types of scale. There's an amount of data scale, but there's also the scale of the systems that we are monitoring. So the number of applications, services, and the infrastructure. On the other side of the equation is how do I find and use that data for answers? And again, the problem there is doing that at scale. How do I find that data? How do I find the right data to look for? How do I correlate that with other data so I can get the big picture? And it seems to me that we spend a lot of our time on the left-hand side of this, a lot of our sort of engineering effort. And when I was here at Monitorama last year, I was sitting in the talks and sort of really feeling like there was a lot of effort and engineering smarts going into the collection side. Doing this at massive scale. So this is Suman from Slack talking about sort of their petabyte scale data collection pipeline. Pretty awesome stuff, pretty impressive stuff, especially at that scale. My favorite slide from last year was this one from Natalie Serino around the timeline of an observability project. What you think it's going to be, set up, the left-hand side of that equation, and then all the fun stuff, right? Using that data to provide value to my teams and to my business. The reality, that setup actually takes time to find how you collect that data, moving that data around, storing and maintaining that data. And then the fun stuff, the good stuff, the value to my business, actually not enough time to really focus on that. And we end up just defaulting to a lot of the practices that we've always had. Now, when it's engineering time internally, and perhaps we're spending on storage costs and so on, and we're sort of rolling our own, it's actually sometimes quite hard to see what the real cost of collecting all this data is. When we pay an external vendor, that cost can be very clear. This has sort of come up. I'm surprised this particular tweet hasn't sort of appeared yet in the slides, but obviously it came up in Joe's talk on Monday around the cost of observability, just really maybe have gone too far and not sustainable. Now, this is just sort of one data point. It's a little bit of a moment where I think we're all sort of checking how much we really are spending and how much value we're getting out of our observability data. So when it comes to these two sides, we seem to be focusing a lot on the left and perhaps not enough on the right. And there's really sort of two questions. How can I spend less? So how can I spend less effort, spend less of my time, and ultimately less of my sort of business money on the collection side, and make sure that I'm maximizing the value of using that data, making sure I get visibility of my systems and my applications, make sure I can understand my systems, make sure I can find answers. So what I'm going to be talking about today is how we can do both of those things, spend less on the collecting side and hopefully get a lot more on the using side. Now, at the moment, all observability roads lead to Open Telemetry, the hot new project. High quality, ubiquitous, and portable telemetry to enable effective observability. That's from OpenTelemetry.io. Pretty much says it all. I think we all absolutely want that. And no wonder that it's the second most active project after Kubernetes. When we typically hear about Open Telemetry, it's normally around this issue, which not about that issue, but about this issue, which is vendor lock-in. We have deployed perhaps a proprietary, and when I say proprietary, it doesn't necessarily need to be a paid-for third-party piece of software. There still could be an open source project or a technology that you've deployed. We're having to deploy proprietary instrumentation in our code. We deploy perhaps proprietary agents on our infrastructure. They're using a proprietary protocol to store that data back in some matching proprietary backend, the metrics, logs, and traces. And to change this is very hard indeed. And that's sort of generally what we hear about Open Telemetry solving, is providing us portability. So replace that with Open Telemetry instrumentation, an API and SDK on the code side. That allows us to then ship those signals out through the Open Telemetry protocol, either to a collector where we can do some control plane stuff there and then sort of filter and enrich that data and then send it on, or we can send it directly to backends that either support that Open Telemetry protocol, or we can have some code and some software in between, just as adapters that effectively allow us to swap in proprietary protocols at any point. So this is generally what we hear is Open Telemetry giving us this freedom of where we send our data when we're collecting it, and making sure that we have that freedom of choice around the observability backends. So hopefully, as we start to adopt Open Telemetry across the industry, we will have solved the problem of getting data in, giving us a lot more flexibility and making sure it's a lot less effort to do this. But what about the problem of getting the data out? So again, that other side of the equation. Once it's in those backends, what about getting the data out? And this is why I wanted to talk about the other bit of Open Telemetry that doesn't often get talked about. We often see that diagram, we often hear about the instrumentation and the controller and so on, but the other bit of Open Telemetry is perhaps, certainly from my point of view, the most exciting bit, and that's Open Telemetry semantic conventions. I've got to admit, it's a bit of a scary name, but it's a very simple and powerful concept. I sort of find anything with the word semantic in a little bit off-putting. I'm not sure where it's going to go. It always feels a little bit pedantic when they talk about semantic. But it is a very simple and powerful concept. If we take a look at our telemetry data, so sort of a simplified view of what Open Telemetry gives us, we have our metrics or sort of time series as they're stored in our database, with metric name, instrument type, units, and data points. We have our logs, timestamp, severity, the actual log body, and our traces, or more specifically our spans, right? A name of a bit of a work, the context, which we can then flow through, the parent spans, start, end, and the status. So that's our telemetry data. But what Open Telemetry does on top of that is add attributes. Now, we're quite familiar with these in the world of metrics. These are our labels that we store with our data points. But we can do the same with logs, and actually Open Telemetry separates this out from resources and attributes, and I'll talk about that in a second. And we can also do that with our spans. We can add in these arbitrary key value pairs. So that's pretty cool. So as well as the actual data, whether it's sort of a metric or a log entry or a bit of work that's being done in a span, we can attach attributes to that. Now the problem is what should these attributes be? They can be anything. But we don't really want them to be anything because otherwise we're going to end up in a mess of data again. And that's all semantic conventions are. It's giving us a standardized set of attributes to use. So just as an example of one, the sort of probably the most essential attribute that Open Telemetry really sort of, requires and expects you to provide is the service name. And that is going to describe the resource effectively where the telemetry is coming from. And this is one of the sets of resource attributes that semantic conventions provides. So a very simple example, this is taken from the GitHub repo where all of these semantic conventions are defined, and so you've got sort of nice change control, and you can see see changes around these semantic conventions when they do happen. So here we've got the attribute name, service.name, so that should be the key, the key string, and it gives us the fact that it should be a string, gives us a description of it, gives us an example, and it says it should be required. But what's really cool about semantic conventions is it even explains what the value should be. So here it's even explaining that it should be the same for all instances of a horizontally scaled service. If it's not specified, use unknown underscore service with the executable name, or just unknown underscore service if we don't know the executable name. So really nice prescriptive information, guidance around what values we should actually be using. So that's a very simple one. Once we've got service name attached to all of our telemetry, we can now very quickly find the logs, metrics, and traces for a particular service. So we can filter across any database that's storing this data and pull out the relevant data. So very, very sort of powerful way of just making sure that at a basic level we can pull out relevant signals. The resource attributes, though, cover really pretty much anything you could imagine, used to describe sort of things or entities, again, where the signals are coming from. So functions as a service. We'll have the function name and the function version. often also then combined with the cloud resource. If that's deployed, obviously, on AWS, GCP, or Azure, we'll have the resource ID. But again, we can see here that they're standardizing the names of those key value pairs. If it's running in containers, we'll have the container name ID in the image and so on. If it's on just a host, the host ID, even, so, for example, the OS. So all of the signals that we're collecting, we're now collecting standardized metadata about those signals. And that's going to be amazingly powerful when we want to start searching for the right signals. So for example, if we use the resource ID here from some logs, we can now correlate that with perhaps some configuration data that we're pulling out of our cloud APIs. So if we're connected to AWS, we can correlate that with perhaps some AWS status. So as well as resource attributes, semantic conventions define some trace and also log attributes. They can be used in either. And these describe the execution context. So if you're making an HTTP call out to a server, what's the information about that server? If you're logging something from a particular bit of code, like an error, you can include the code specifics. And I like these on the end, the other pieces here. We've got things like even like the end user ID. So if we are going to track the user ID in perhaps some logging or some spans, don't just make up whatever your key value pair is, use enduser.id. If we're actually using feature flags, so this ties in with some standardization in the open feature spec as well, we can include that in our logging. So we've got a much better understanding of what's going on, and we're able to correlate this information with other data. So for example, if our logs consistently use enduser.id, then we can more easily correlate user-specific logging with other data, like our service desk data or our customer data. And there's many other attributes that semantic conventions provide. I'm just providing a little sort of sample here, but anything to do with databases. Semantic conventions also, on top of all of that, standardizes the names of our metrics, what instrument types they are, and even the units. So the more the data is standardized with Open Telemetry, semantic conventions, the more straightforward it's going to be to use that data, because we know what data we're actually have in our database and how to use it. So an example metric, for example, we've got the name, http.server.duration. It should be of histogram type, and it should be seconds. And then you can see that with the metric, it's also defining the attributes that should accompany that metric. In terms of metrics, there are a huge number of them. Again, all standardized, so rather than proprietary tools and different open source implementations of data collection using arbitrary metric names, we've now got a standard set of metrics across pretty much anything you could expect. If you're thinking, well, how am I going to keep track of all of these things? The good news is that a lot of this instrumentation is automatic. That's a big part of what we get from Open Telemetry semantic conventions. We just have to say, instrument this stuff. Those implementations will use those semantic conventions. So in many cases, we don't even need to think about making sure we're collecting this in the standard way. We can just sort of consume it in the standard way. If you do set custom attributes yourself, obviously the guidance is to try and use those semantic conventions wherever you can. And those semantic conventions are just going to be building, so hopefully there should be something relevant to what you're trying to track here. I perhaps should have started with this, that the semantic conventions is currently, most of it is in an experimental status. The good news is it's moving rapidly towards a stable status, so there's a significant effort underway to reach stable. One of the big sort of pushes at the moment is that the group there are merging in the Elastic Common Schema, which defines a lot of these semantic conventions for logging. So that's sort of hopefully one less standard to have in the community, and we consolidate around Open Telemetry semantic conventions. A particular note is that those HTTP attributes that I mentioned just there, they've changed significantly. So if you are looking to start to adopt Open Telemetry over the coming sort of months, consider your semantic convention compatibility. In particular, I think the current plan is to have new implementations use the previous experimental schema, and for you to actually have to opt into the stable schema. when it's released. So if you are starting to deploy Open Telemetry, you might want to opt in to use the forward-looking stable scheme. There's a link there. I'll provide the slides after the talk if you want to just follow through to that and just sort of read that guidance around the move from experimental to stable. So that's Open Telemetry semantic conventions in a nutshell, hopefully. And so coming back to the why, so what's so important about this and how's it helping us spend less and get more? Semantic conventions will give us greater portability of data, which I'll talk about in a second in more detail. It's also going to give us greater usability of that data. We're going to be able to find that data more easily. The tooling that sits on top of that data will be able to leverage those semantic conventions to give you much more guidance around what to look for and how to correlate it with other data. And that data is going to be much more connected to data outside of our observability data. Like that example of the user ID being able to map onto our customer databases more easily, or the resource ID mapping onto the information we have in our cloud providers. So I just wanted to finish with a sort of few discussions around this and sort of the hopes and dreams of what Open Telemetry semantic conventions will give us. I think, first of all, when we come back to this idea that Open Telemetry gives us the freedom of choice, I think there's less freedom than we actually think. Although we can send that data to any observability backend, typically those observability backends are tightly coupled with the front end, right? We send it to one vendor, one full stack observability tool, or perhaps the visualization layer that comes with sort of the trace database. We're often tying into the front end by sending the data to the back end. And I think the Paige talked about this a little bit around that sort of single pane of glass yesterday. Can we always send all our data to one tool? Once we start committing to one tool, we feel like we need to send all that data to one tool. And often we end up spending on putting that data into that tool just to get it out in a standardized fashion. So even, for example, if we might be sending some data to AWS CloudWatch and paying for it there, we then have to pay to get that data into our tool that we're using for visualization and analytics. So we pay for it twice by moving into that second tool. So by locking the sort of back ends into the front ends, we're actually locked into, I think, a vendor still as more than we sort of realize or that you expect from that Open Telemetry collector architecture. So what semantic conventions will give us is that idea of standardized connected data being stored in those databases. So we can collect it, we can send that data to any database backend we want, but we'll know that that data is in a standard format, which means that we can plug front-end tools into that data across any database. And so that's going to allow us to choose our backends more wisely. We're not going to just be sending it to the back end that's coupled with our front end. We can send our data to the back end that's going to work best for scale, cost, and performance, using David's three measures yesterday from storage. And I totally agree with David when he said around the back ends will become, or the storage layer will become more commoditized. We shouldn't be having to send these tools, this data to particular tools just to get the data back out again. We should have free choice. And it may even be multiple different tools. Because this data is standardized and connected across, we can correlate logs, metrics, and traces across those three. And we can also correlate it with data outside of metrics, logs, and traces as well. So we can send to an optimized metrics database, an optimized logs database, and trace database. We could send to multiple different databases. We can leave our AWS data in CloudWatch, but we'll take our containerized logging through into Prometheus still and have multiple different places where this data is stored. But that's okay because the data is going to look the same wherever it is, and it's going to be connected across those data stores. So it gives us a lot more flexibility, so we can start to spend less on where we store the data and focus a little bit more on how we're using that data. And of course, then when we choose that front end, we can really focus on the use cases and the value that those front ends provide. And there's so much opportunity for the visualization, but particularly around analytics. Obviously, we haven't heard much about AI this week, probably in a good way. There's so much more to do there with the data we collect. And we don't necessarily want to be locked into one vendor because they have a cool analytics capability. don't necessarily need to pay to store the data in that tool just because they have that cool analytics capability. Ideally, that analytics capability would sit on top of the data where we have it and wherever we want to store it. So we're heading towards that standardized connected data. I think it's going to be a fantastic thing for our community in general. And when it comes to sort of hopes and dreams, I think this is sort of the one big step that I hope we can make, which is, can we build a standardized observability query language? So the good news there is that there is a new working group under the CNCF to look at this. It was mentioned yesterday by David as well, looking at a query standardization. So they've already looked at and surveyed a lot of the query languages out there. You can see just I'm not sure if that's a complete list, but certainly that's the list that's in that charter. Now, whilst other domains like business intelligence within our businesses, they standardize around SQL, right? It doesn't really matter where the data is. They can run SQL queries against it. Within the observability space, we've ended up with a number of different query languages. And again, it's tying us in to a particular back-end and front-end. So can we get to one common standard? I'm going to be very excited to see that. And it ties in very nicely with those semantic conventions, because as well as having perhaps a standard query language, we know that we can query against particular attributes and for particular metrics, and the data is going to come back in a standardized, expected way as well. So real, true portability of our data. And then just to finish off on, I think, really the sort of true power of semantic conventions and what I hope we're going to see a lot more of is accepting the fact that although we talk a lot about metrics, logs, and traces, we cannot achieve our goals, we cannot troubleshoot those issues and deal with those unknown unknowns just by looking at our metrics, logs, and traces. It's just not enough context. There's so much more going on in our systems that is beyond what we're collecting with our observability data. So for example, our applications are running on infrastructure where we've got some configuration data somewhere. That is not stored and not considered observability data, but it's key to working out what's going on and where to look. The status of that infrastructure, if it's a third party, the cost of that infrastructure. Our developers, of course, are making changes, so code changes with pipeline deploys, and we're tracking issues. That's not considered observability data, but it's absolutely key to troubleshooting problems. And then if we look more sort of on the customer and user side, on the user we have logons, purchases, service desk tickets. This is all absolutely critical stuff to understand what's going on in our system, but it's not considered observability data. And ultimately the business, aligning what we're doing as observability practitioners with what our business needs, which is to make sure those business metrics are performing. And so what semantic conventions will allow us to do, and what I sort of touched on when talking about some of those conventions, is allow us to tie our metrics, logs, and trace data with data in that sort of broader scope of things, whether it's tying in users with user telemetry and product analytics, or the metrics associated with business metrics like cart conversions, or tying in resource IDs to the infrastructure data as well. And so ultimately what we're trying to get to, which I think a lot of us are now starting to talk about with connecting data, is using graph analytics and connecting the dots across our data to fill out that whole model of our systems. Now, I know Dylan talked about this yesterday around that sort of mental model. We really need help to understand how our systems are constructed, how they're connected, and how this data is correlated. So, for example, when we are needing to troubleshoot an issue with customers having a problem with our application and they're raising tickets, typically what we're actually trying to do is not sort of where do I look initially, is who do I get involved? Which dev team have potentially made a change that I need to track that to? And that's my challenge. I've got the customers raising tickets with a particular issue, and I'm trying to find out which dev team I need to escalate this to, because there's perhaps a change that's been made. So by correlating data using those semantic conventions, we will be able to map all the way through from that customer-facing data to our dev team data and those changes and those deploys. Even though that's not considered observability data, we need to leverage those metrics, logs, and traces to understand how those two customers and dev teams are related. So I talked about this at Observability Day at KubeCon, North America last year, so if you want to go learn more about that, I talked about why large-scale observability needs graph. At the time, I wasn't super aware of semantic conventions because not many people were talking about it. But it is absolutely essential for us to start mapping our data together and having true portability of our data. So to summarize, Open Telemetry semantic conventions, scary name, very simple concept, very powerful concept, which is standardizing the data we collect. So greater portability of data. We can send our data to different backends, knowing it's going to be the same data, which means that we can get it out more easily. Greater usability of data. The data we have available to us, standardized across all of those backends. We don't need to go searching for particular metric names or trying to correlate logs and metrics with other data. That's all going to be fully standardized for us. And greater connectedness of data, connecting our observability data, or what we think of as observability data, with actually that bigger picture observability data. So hopefully that's useful. You've learned a little bit about semantic conventions. Appreciate the value of it. I hope there's much more to come. So in future Monitoramas, we'll be talking about this a lot more and seeing a lot of those sort of potential wins with this becoming a reality. So thanks very much for listening. That's the end of my talk. Feel free to drop me an email, look me up on LinkedIn, or come up to the booth, and I'll be on that talk, Richard Benwell channel, and I'll drop the slides in there if you'd like to check them out later. But thanks very much.
Great. Thank you, Richard. Are there any, we've got a few minutes for questions. Are there any questions from the audience? Jack's got one.
How do you encourage your developers, your engineers to use the correct semantic standards?
How do you encourage your developers or engineers to use the correct semantic standards?
That's a really good one. So I said on that slide there that we have the auto instrumentation. So where possible, that should be leveraged. Hopefully, we won't see the use of free-form strings. You can also import libraries from semantic conventions that allow you to sort of look up through all those strings. So we shouldn't have to be to get too messy with the actual sort of string values. But it is a good question about how you make sure that when someone's dumping a quick log, they actually are even bothering to add those attributes, let alone using the semantic attributes. And I think that comes back to perhaps a whole other question, which is how do we engage our developers more with our observability data in the first place, right? If it's outbound, if they're responsible for producing it, but don't have to consume it, it's going to be very hard to convince them to set the right data. If we can start showing that data back to them and showing sort of the value of that data back to them, I think they'll be incentivized a little bit more to make sure they're adding the right attributes. So that's a really good question. I think we'll have to see how that pans out, but I believe that's really fundamentally about engaging our dev teams with observability data in the first place. Otherwise, it is going to be very hard to get the right data.
Yeah, great question. Any other questions from the audience? Yeah, we got one right here.
Curious, how does the semantic conventions version online with like the baggage API use convention? Like, if we have the ability to use that, should we gravitate towards the semantic conventions?
Yes, I'll repeat the question. How does it relate to the baggage API? So the baggage is allowing you to sort of flow through metadata, right, across your spans. So again, that supports, and we should be using those attributes when we're flowing that through. So if you are wanting to pass data along through your traces, through your spans, then you should be passing it using those key value pairs as defined by the semantic conventions. Does that make sense? Is that the question? I mean, sort of the idea here is that semantic conventions are literally a standardized set of names, and values, and we should be using those wherever we're effectively using metadata.
I think that was on the top right. Yep.
There are already well-established standards for meta exploitation, such as parameters or input video per byte. And so my question is whether it is a good idea to try to apply the semantic conventions to already existing standards for meta exploitation instead of inventing out your own open telemetry format for the text processing. The same applies also to logs.
So basically, does it make sense to create these semantic conventions when there's these other standards, right? Yeah.
The question is whether it's better to use already existing established standards for metric exploitation, which everybody uses and everybody likes, instead of creating our own standards for metrics transfer exploitation for open telemetry and
Yeah, so sort of, given existing standards and implementations that are out there in the world, right? Like Prometheus, should we be trying to sort of move towards a common standard? I think one of the things that Open Telemetry does very well is allow quite a sort of plug-in, a plug-in model where you can adopt certain elements of Open Telemetry. You can, for example, still continue to sort of pull that data into Prometheus in that current format, and additionally sort of send it out to another back end. And I think even with the collector allowing you to enrich and sort of filter that data, allowing you to transform that data, it does give you options. You don't have to adopt Open Telemetry. I don't think it's sort of a forced model here. If you've got some existing implementations that they're working for you, I think that's absolutely fine. But I think it does allow sort of incremental adoption, whether that's sort of new deployments, new instrumentation, and allowing you to use that. So yeah, I think I do think it's a great to have a standardized model. I think it's amazing work that these teams are doing. And I've got to say, this is not any of my sort of my work. There's people in the audience here on those working groups. I think it's pretty incredible, the effort that they're putting in to try and standardize this, because I think it is the answer to getting a lot more value out of our data, is to try and standardize it.